Okay, so first I'll go over each of the problems, and then I will run all three of them at the end. So the first score, the first problem is going to be the test scores that we did in problem 3, I think it was. So first I'm going to use the scanner to receive my input from the users. I know we can also use the J option pane, but I chose to use the scanner here. And I'm going to name it scanner. I've got my variables defined right here as doubles for score 1, score 2, score 3, and the average. I'm using the scanner to prompt for input, and I'm asking the user to enter the first score right here. I'm going to store it in variable score1 and display that using the print line. Sorry, I'm reading off of another screen and trying to look back and forth. I'll try to hover with my mouse over what I'm speaking of. So I'm going to use the scanner to prompt for input. They're going to enter their score. It's going to be stored in the variable. I'm going to use the same method to store the input for scores 2 and 3 right here. They're also defined by the variables, score 2, score 3. Once we store all of the user variables in these doubles, and I chose doubles because the test scores can be, they're going to be numbers and they can be decimal numbers. You got a 95.8 or 71.2 or something like that. Then the program asked us, or the question asked us to make the program come up with the average of the three, and that's just what I've done right here. Obviously, with the three scores, just score 1 plus score 2 plus score 3, and I'm going to divide them by 3. Then I'm going to use if and I feel like this is where it started becoming similar to other programming languages that I've learned. I'm going to use Boolean values in combination with these this if-else-if structure right down here, beginning with if the average is below 60, as that is, because you can't get anything lower than an F. So if the average is less than 60, I'm going to use system.out.print. The average score is, whatever the score is, and that's grade of F. This percentage F here is my format specifier. In this case, it's float. And you'll see when I run the program, I think it goes to 6 decimal places by default. If I wanted to limit it to just 2 decimal places with rounding, I think I could do %.2f. So else if the average is below 70, it's going to be a grade of a D. Else if below 80, it's going to be a C. Below 90, it's a B. And here I used if the average is less than or equal to 100. Let me go to my other page. I could have just as easily just stuck with the less than and said 101, but you can't have an average of higher than 100. So that's also kind of a method I've put down here for catching those exceptions, or an average that's an invalid number. It just states that anything that's not below 100 is going to be an invalid average. I don't have any sort of catch exception for grades less than 0. Here's the race problem. Again, I'm importing the scanner. This problem was ridiculously convoluted. My code here is pretty long. There's so many options for who's going to finish the race first, and I'll review all that below. Again, so I'm using the scanner. I've got my variables stored here as strings for the name, to enter the name of runner 1, 2, and 3, and I've got my variables here stored in doubles for the runner's time that they finish the race. This string race results here is part of the string that I'm going to create as one long string to give at the end. At first it's empty, right here, but it's going to be filled in depending on which racer finished the race first, and it's referenced below, and I'll come back to that. Sorry, let me just look at my other page here. Runner 1 times scanner equals next double. Where is that? I'm going to use 3 instances of this scanner next line here. Otherwise, it causes the program to skip, and it won't let me enter in the second or third runner's name if we don't have these scanner next lines here. let's see. Okay, so yeah, this first set here, this big block is going to assume that runner 1 comes in first, and I've got that right here. If runner 1 time is less than runner 2 time, obviously a faster time would be a lesser number, and runner 1 time is less than runner 3 time, meaning runner 1 did finish first. Then my race results string, which is that thing I was going to reference later, is going to turn into, runner 1 name, whatever name you give him, has finished in first place, plus it's going to recall that double value for his time, and that's going to be in minutes. I've got, else if here. This is going to assume that runner 2 finishes a race, if runner 2 time is less than runner 1 time, and runner 2, it's important, these and runner 2 time is less than runner 3 time, then obviously the race results is going to go, runner 2 name finishes in first, and runner 2 time in minutes again. The same method of filling out a string used above is used yet again here with runner 3 finishing first. Let me see my sheet. At the bottom here, I've just got a simple out print line race results. This race results, again, like I said, it's going to change, depends on who finishes the race first. So it just got really, convoluted in here with different people finishing the race at different times. The BMI example was much simpler. Yet a third time using the scan here because I think it's easy to use in the J option pane, or I'm more used to it anyway. I've got my variables stored here, user height, user weight, which will all be calculated, or which will all be used to calculate the BMI, of which I have the formula right here. It was user weights times 703 divided by user height squared, so I just multiplied user height by user height to get that squared value. And I just, as in the first problem, I'm using an if-else structure so that if the BMI is less than 18.5, it's going to print out the person is underweight, and if the BMI is less than 26, you'll have optimal weight. But of course, if it's less than 26 and less than 18, it's going to go back to underweight. Else, anything else, meaning anything above 26, the BMI is going to report that the user is overweight. So I'll just go ahead and start running with this program. I'm going to enter in my weight. Oh man, maybe I shouldn't give this away. 165 and height in inches. I'm about 6 feet, so let's say that's about 72. And oh, okay, good. I have optimal weight. Let me clear that console. I'm going to run this race. Please enter. Nope. That's the weight again. Let me try it for test scores. Okay. Test score average 100, and then they did really bad. They got a 50, and then they did okay, and they got an 85. Their average score, oh, maybe they didn't do okay. The average score is 78. And again, I've got it floating just to those 6 decimal places. I can clean that up if that's needed to be. And it reports back with a grade of C. Okay, so here, running the race. Let me clear out this console and run the race. And let me start that. The first runner's name, let's use one of the cats. That'd be Pete. The time in minutes, Pete, he's pretty fast, so he finished in 2 minutes. Second runner's name is going to be Taco. Taco is a pretty slow runner. He's going to finish in 4 minutes. And the third, let's just say that's me, and I don't want to win. I'm lazy. I finished in 8 minutes. So Pete, he's fast. He finished in 2 minutes, first place. Taco finished in second. Taylor finished in third at 8 minutes. I think we're all good.